Okay, part two.
Part two. All right, check your understanding. MK, read number 1.
Shuffle a deck of cards, turn over the top card, put the card back in the deck, and shuffle again. Repeat this process 10 times, and then let X
All right,
equal the
is
number of
that
aces.
better?
Yeah.
Yeah, that's the one that we were discussing previously. It worked this time. All right, read 2.
Choose 3 students at random from your class. Let y equals the number who are over 6 feet tall.
That one's just like, what are you even testing?
It's just like what?
What are you even testing? Just the number of people who are over 6
So
feet?
yeah. So we have success and failure. Is 6 feet over 6 feet or not?
They don't have a number. Would the number of trials be 3 because it's 3 students?
Yeah, I guess.
We have
And they are
independence because
independent.
they don't.
Affect each other's
But is
height.
the probability of success
Right.
the same?
It's not.
No, it's not.
It's not because I don't know. It's like whenever you don't put the person back into the mix, it changes the probability. It's sort of like the cards one that you had a minute ago. So it's not. All right, and MD, read 3.
Flip a coin. If it's heads, roll a 6-side die. If it's tails, roll an 8-side die. Repeat this process 5 times. Let W equal the number of 5s you would roll. That's no.
Why?
Because it doesn't, not equal probability.
Right,
for-
it's not equal probabilities. All right, so that's the gist of that. All right, let's go on and do a little bit of math. Yay!
Is
So,
this the done for the day for this?
no, it's still on here. We're still on. Now we're going to do how to calculate probabilities when we use a binomial random variable. So let's go. This is a blast from the past, pre-calculus. So, all right, what I need to do, if I give you, say, 4
Plus or minus
spots, 4
Oh, no.
spots on the shelf.
Oh no.
That's
No,
fine.
no,
You
no.
can do this. You can do this.
Oh, I thought we were
All
playing
right.
him.
And I have 2 objects that I'm going to sit in the spots. So I could set the object in slot 1 and 2. So I want all the different ones that I can come up with. So MD 1 and 2. What else?
2 and 3,
2 and 3. All right, MM.
3 and 4.
All right, MK.
1 and 4.
All right, MD. Is there another one?
1 and 3.
And make sure we're not repeating any. MM. Is there any more?
Yeah, 2 and 4.
2 and 4? We don't have that. All right, is there any more? MK?
I don't think so.
Okay. That's it? Anyone see
yeah.
another one? What?
No, just kidding.
No, that's it. So 1, 2, 3, 4, 5, 6. So, do you remember what we call that in mathematics class? Does it matter if we put, these are identical objects, they're check marks. So, does it matter if I put check mark here, here, and it's the same outcome?
Commutative property.
You know, it starts with a C though. It's called
Continuity.
it's called a combination.
Yeah, I was
Now, in combination, the order doesn't matter. So, the order doesn't matter in this. So, we have a combination of 6 objects taking 2 at a time. So, we want to tease that out of our not 6 items. We have 4 objects or 4 spots taking 2 at a time. So it's 4, sorry. So we have 4 slots filling 2 of those at a time.
This
It's
is where you
called
do
a
the
combination. It's called a permutation if order does matter. So, all right, so let's say that we have to remember how to do that. Anyone recall?
Do you start with the 4 or the 2 on top? Is it
4 on top. 4 what?
The what's it called? The exclamation.
Yeah,
point.
4 is good job.
Oh.
And then you do.
I remember we tried to learn this and it was, he didn't,
And what?
we didn't understand it.
Oh, all
I
right.
just went on my
should come and
calculator
just had
and found
pre-calc.
You
exclamation.
can't just stop there. All right.
And then is it you subtract times something else too, or plus
Yeah,
or something?
down here. And in this one, you end
Minus
up
2.
doing this number, whatever's sitting there,
2
and then the
times 4
difference
minus 2.
between these 2 numbers.
Just 2.
like that. So let's see if that works and it would get a 6.
4 times
So the
3.
quick way to do is to stop at 2 factorial. Why do I stop there?
Because you can cross
All
it. Yes.
You've been well
I
taught.
learned something.
All right, so we have a 4 divided by 2 factorial, or 4 times 3. 12 divided by 2 factorial, which is 2. So we did get the desired 6.
Cool.
All right. So
Actually, I liked that part of it. I thought you were gonna do when we had like the probabilities where you would write the numbers and then we would. I just did not like that.
okay. All right. So now we have to, let's do a general formula. N objects taking k at a time. The way our book writes that, that is a symbol that we often see for combinations. It's also written like this. Have you ever seen it like that? That means combinations as well.
There's
That
no line.
means the combination of n objects taking k at a time. So the general formula is n factorial over k factorial times n minus k factorial. I used R in math
I was gonna
class,
say it is a
yeah.
lot.
They use k in this book, I believe. So, all right, now this has a name. It's called the binomial coefficient. So that's part of our math for today. And we're going to develop the other part by example as well. So then we'll go general. So keep this on your plate. I'll erase everything else. Keep this. This is the important part. Of course, it would be in the center of the board, but oh well. Like I said, in student teaching, you had to plan your board space, so I would have gotten that grade. All right, let's go ahead and look at an example. We'll do this O, the O thing. So I didn't think I copied this for you, but we can just take a note on it. Say that you are looking for blood type O, and say the probability of type O on any birth is going to be 0.25, which we just looked at, and the probability of none. Let's talk about that. So the probability of no O. So to calculate that probability from probability class, we now know that these are independent, so we can multiply each of the probabilities. Now, what is the probability on the first birth of having a no type O? MD 0.75. And the second birth?
0.75.
All right, so we end up doing 0.75 to the fifth. Right, so the same thing. So,
0.24.
all right, cool. 0.24. Thank you. All right, so now let's talk about, it's not so hard when it's none. So you follow that math?
Yeah.
When we get to the probability of 1, it gets more complex. So the probability of having 1 in the next 5 births. So let's do one scenario. Say the birth was the first one.
Oh,
so
you
what's
have
the,
to do like
Yeah.
all of the scenarios.
yeah, we're gonna have to do them all. So, but we'll eventually just reduce it to a formula. So we're just trying to derive that formula now. So, what's the probability, MK, of having the first one born type O,
0.25,
and the second one not,
0.75,
and,
0.75, 0.75, 0.75.
So isn't it just 0.75?
alright, so that ends up being 0.25 times 0.75 to the 4. So just notice the relationship between the exponents, that might be observable.
It's
Miss Paul, did we do
0.08.
this last year too a little bit?
Yeah, we did. Alright, so now, what's another scenario that still meets the requirement of 1?
0.20.
So we could have the birth on the second one, right?
Right.
So then what would
But it's
these
the
all be?
same,
Right.
technically.
The same thing.
Alright, so how
multiplied
many
by
of these are we gonna have?
So like 4
Five.
times 4.
Right, so we're gonna
No,
have
times 5.
5 counting
I mean,
that one.
that's what I meant.
Alright, so there's gonna be identical, there's gonna be 5 ways we can meet that. So we're gonna have to put a 5 in front of that.
Oh.
Alright, so now, observe that, we're gonna come up with a rule, so just observe that. Notice when we had a 1 here, 5 choices, we got a 5 out of that. Alright, so we'll see if we can see more patterns. Let's do the probability of 2. So, alright, MK, what's one thing that we could do to meet this requirement?
You do 0.25, 0.25,
Alright.
and then 0.75 for the rest.
Alright, so what's that look like? So we got 0.25 twice and 0.75 3 times. Notice the relationship between the exponents. So you should be seeing something. But how many of those are there?
10?
There? Well,
I'm
it
just
would.
guessing.
Is it 10?
I don't know.
What it is, we can calculate it though.
Would it be 6?
We can
We
do,
just did it up
there are 5 slots and we want 2 at a time. So what is that? So looking at the formula that we developed, when we had a 4 here, we got 6. When we had a 4 here, we got 6. But we have a 5 here. So let's pull out our factorial math. 5 factorial over 2 factorial times 3 factorial. So I'm going to do 5, 4, 3. I'll stop there. That crosses out. So 3. I just said 10 in the beginning.
Me?
How'd you know that?
Just guessed.
You guessed? All right.
Well,
All
just
right.
because like it's reasonable that if the first one was 5 and it was 1, then the
Right.
second one, if it's 2, you just multiply it by 2.
Right. All right, so what am I going to do? How can, without me writing it out, can you see the pattern?
Yeah, so it's gonna be
What's
10.
going to happen? What's going to happen for the probability of 3? So how many times are we going to use 0.25 mm? How many times are we going to use 0.25 for 3?
3.
And how many are we going to use
2.
0.75? And then we'd have to use math to do 5 over 3. Anyone know what 5?
Wait, 5 over 3?
5 items,
Oh,
5 birds
sorry.
taking 3 at a time being O's.
5 over 3 factorial? That would be.
It's the same thing.
Yeah.
It's 10.
10, it does come out. Did you notice when this number is changed to this number minus this one, it's always the same.
Oh.
So 5 over 2 is 5 over 3. It's pretty cool. So that's 10. So you can see probability of 4, I'll put it up here, MD. What patterns are going to follow here? What probability, what
It would be
combination?
0.25 raised to the 4th
Right.
times 0.75.
5 over 4.
And then
5 over 4. Right, not fraction. So what is 5 over 4?
Factorial? It'd just be 5.
5 over 4.
Yeah, it's just 5. Because you see the factorial, this will be 5 over 4 times 1. So it is 5. So that's also true. When this number is different from this one by 1, it's going to be the top number. So that's another math trick. So how many more do we have? Probability of 5. So try that one, MK.
0.25 to the 5th.
Right. And
That's
well, we don't use any 0.75, so we could raise it to the 0, which is 1. And then out front, how many ways can we do 5?
1.
When there's only 1. All right, can we develop a formula for all of this now?
Yeah.
All right, so say this time, so the probability that the variable, I'm talking about x, equals some value k. Is that what I want to say? Do I want to say k? Yep, k is good. All right, so the probability that x equals k. So in this one we were saying that O equals 1, O equals 2, number of O equals 3, O bloods. So in general then, we're going to use a binomial coefficient. So we're going to do an n over k. I'm going to let you remember that this is what that means. I'm just going to write it like that. And then it's going to be followed by what? Can you go general from this? What would go in here? The probability right?
Probability of yes.
Yeah, all right, so we'll just call it P. And so the
It's
probability, P raised to
probability of-
what compared to these two numbers?
P decay. Decay.
Is it decay?
Yeah, it's
It's
decay.
decay, because if I wanted 3 O's, like on this line, didn't we take 0.25 to 3?
Right.
When I wanted 4 O's, didn't I take 0.25 to 4? So this number always matches this. And how could I, so this will be the other probability, P, and what's the probability here? See how these relate, 0.25 and 0.75? This will always be what then? 1 minus P. You see that? So this was 25, this was 1 minus 25. That will always work because everything is divided into failures and successes. So if you have the success here, this is going to be a failure.
Well, then what do you raise it?
Yeah, what do you raise it to? Let's look and
It'll
see.
be
N minus.
N minus K.
Is it n minus k? I think you're right. All right, this is right. This is called the.
Puzzles.
Theory.
Same.
That's the general form. If I'm looking that up,
Now when I have to look at this again, I'll be like,
what?
what? But it's okay because I have an example, so I'm gonna do it.
This is the formula for finding a binomial probability.
That sounds so smart.
All right,
Yeah, I can tell you I know how to do binomial.
let's try to do.
Level.
Let's try to do several things on our calculator, and then we'll do one. Oh, this looks like we're ready again to stop.
All
All
right.
right.
Part 3 is coming.
All
We've
right.
gotten so